So hello Mr. Subramaniam. Today we're gonna talk about our physics assignments, and we're gonna talk about the question how is the mass of the object that is hanging on a pulley is going to pull the block on a flat surface, and how it's going to affect the acceleration of the whole system. So in this question we have 4 different sections. First of all, we gotta illustrate free body diagram for each block. After that, we gotta write down the second law of Newton for each block. Third one, we gotta find the acceleration of each block, and then we gotta find the tension in each string. Here you can see the materials which we used. So we took all of the materials from Appendix A, table with rough surface, 2 blocks with smooth surface, 1 block with rough surface, and the string and the 2 pulleys. The pulley has no mass and friction. So here we illustrated how the first figure is affecting. So here, as you can see, the mass of the A block, which is M1, is 4.5 kilograms. Here you can see that M2 is 2 kilograms, and the M3 is 3 kilograms. So the tension is going upwards from the C block. It goes from the right side to the left side, and after that it goes downwards to the M1G. As you can see, the B block is having the Newton's force applied to all of the 4 forces, or 4 sides, and the kinetic friction is being affected to the C block, which is pulling downwards. As you can see, the whole system is being affected by the A block, which has in first figure it has the highest and the largest mass of all, so it's having the highest pulling tension. So here I wrote down the formulas, simplified versions. So as you know, Newton's second law states that the acceleration of an object is directly proportional to the next external force applied. So here we can see that we found the acceleration in our second part, but here we can see that the Newton's second law, we have the mass and the acceleration, which also the proportional to the force applied to the each pulley and each block. So we have kinetic friction. Here's the formula of kinetic friction. The formula of Newton's second law is pretty simple. It's force equals to a mass multiplied by acceleration. Here we found the Newton's second law to the first block, which is M1G minus tension 1 equals M1A. After that, we found to the second one, which we changed the formula. And the thing is with this formula is that here you can see the T1 is in negative, but in the second one it has positive. And also we are adding the T2, tension 2, as a negative. And in the third one, we are changing the negative tension 2 to the positive. So this thing is very important because from this we can identify the net force and the tension of the pulleys and how it's being affected. So now after this, Nurdalet is going to speak about the acceleration of each block.
My name is Nurdalet Imanbek. Let's continue for part C. Find the acceleration of each block. We should find total acceleration of the system is acceleration 1 equal acceleration 2 equal acceleration 3, and all of this equal total acceleration of system. And here we have negative T1, positive T1, of negative T2, of positive T2. Let's simplify this formula. Formula gonna be M1G minus M3G minus friction kinetic divided by total mass. Total mass is M1 plus M2 plus M3, and multiply to gravitation. Here we can change friction kinetic. We can simplify friction kinetic. Friction kinetic is Kn and is equal Km2G. Here we can change friction kinetic to Km2G. Without G, because here we already have a G rotation. And if we calculate this equation, we'll have -4.50 minus 3.0 minus 0.55 multiplied by 2 divided by total mass. Multiply to gravitation. And if we will calculate this equation, we'll get 0.41 meter per second. This is gonna be our acceleration. Next, we'll continue with Nurdolet Ali.
So my name is Ali Nurdolet, and let's start the last question. And the last question is find the tension in each string. So we start from T1. For the tension 1, I'll use the equation 1 I want to isolate. So if I bring it on one side, if I bring it to side M1A to other side, I will have it by itself. So my equation for T1 gonna be look like M1J minus M1A. If we will simplify this for this formula, it gonna be like M1J minus A. If we will calculate this formula, it will looks like 4.50. So J is 9.81 minus acceleration we already find, and it's 0.41. And after calculating, we will get 42.3 newtons. And about tension 2, for tension 2, I will use formula M3A plus M3G. Also, we need to simplify this formula. If you simplify it, it's gonna be like M3A plus J. After calculating it gonna be 0.41 plus 9.81. After calculating, we'll get 30.6 newton. And that's all. For tension 1 we will get 42 and 3 newtons, and for tension 2 we get 30.6 newtons. And we need to discuss our assignment, and Arsen will continue our discussion.
Hello, my name is Arsen. Today I'm going to talk about discussion how is the mass of the object on a pulley pulling the block on the flat surface is going to affect an acceleration of the system. So now I'm going to discuss the theory behind our question. The mass of an object will affect the system acceleration. In summary, the system's acceleration is influenced by weight of the handling object. With a heavier object experience higher acceleration. Block mass of the flat surface is influenced by magnitude of the frictional force opposing the motion. And also the figure 2 has the same solution as the first figure. Since the mass is great, its second figure, the acceleration is also became higher.